All right, we're doing the second free response from review day 9. I was in the middle of this and got interrupted, so I'm just going to kind of walk us through my work up to this point. It's a pretty straightforward problem. We're given a velocity equation. First thing we're supposed to do is find the acceleration, so that's just the derivative of velocity at 3. I threw that in my calculator. I'll show you here. I just did the derivative of y1 at x equal 3, and it gave me negative 2.118. So that was worth 1 point if you did that. Then as far as the position goes, we're going to have our initial position, negative 5, plus the change in position from that time, which was time 0, to the time we want, which is time 3, of the rate of change, which is velocity. So if you put the negative 5, the initial position down, you got a point. If you had this set up, you got a point. And then I threw that on the calculator. First I put it in wrong, I had minus, but then corrected myself, had a plus sign there, and it gave us an answer of negative 1.760. And the 0 is important. It's a significant figure here, so you do have to go all the way to that for this. All right, now part C says evaluate this and interpret the meaning of each. So the integral from 0 to 3.5 of velocity, if we do that on the calculator just like we did a second ago, is 2.844. And this is the change in position from t equals 0 to t equals 3.5. Okay? Then we'll do this other one down here. The integral from 0 to 3.5 of the absolute value velocity is equal to 3.737. And that's the total distance traveled. Now, unfortunately, I don't think the AP is going to have this concept on it this year, although we're very good at it. For whatever reason, they put this at the back end of their units. It used to be in the front end. Whatever the case, I don't think you're going to get questions like this, which is unfortunate because we do a really, really nice job of that. But at any rate, you got 1 point for these answers. They both had to be right. And then you got a point each for the interpretation. So 2 easy points there. Like I said, unfortunately, we probably won't see that. All right, then we get D. And D says a second particle is moving at this with this position. When are the two velocities the same? So what you needed to do is take the derivative of that, which would be its velocity, and that's 2t minus 1. And we want to know when is this velocity equal to this velocity. So we're going to set those equal to each other. So I want v of t equal to 2t minus 1. If you set that equation in some fashion up, you got a point. And then what you do is you already have, maybe you should have v of t in for y1, right? That's in y1. Put this one in y2 and see where they intersect. And they would intersect at 1.570 or 5.71, I think if I round correctly. They'll accept either one on that. All right, if you have that time, give yourself another point. So pretty easy one there. Like I said, some of this you're still could be in play. Some of it may not be, but hopefully this helps refine that idea for you.